The bonds that hold atoms together in compounds are called intramolecular forces. There are three main types of intramolecular forces: ionic bonds, covalent bonds, and metallic bonds. This video will focus on ionic bonds. Covalent bonds and metallic bonds will be featured in their own videos. An ionic bond is formed from the electrostatic attraction between two oppositely charged ions, one positive, the cation, and one negative, the anion. The cation is usually a metal, and the anion is usually a nonmetal. A familiar example is the bond forming table salt, NaCl. Sodium ions, Na+, are strongly attracted to chloride ions, Cl-. When they are joined together by an ionic bond, their opposite charges cancel, and they form a compound that is electrically neutral. Remember this when you write the formula for any ionic compound. The total positive charges of the cations have to equal the total negative charges of the anions to form a neutral ionic compound. You can write the formation of an ionic bond using Lewis dot structures. In the reaction 2Na plus Cl2 yields 2 NaCl, for every formula unit of NaCl, one sodium atom loses an electron, and one chlorine atom gains an electron. We can write the reaction like this. An atom of sodium, which has one valence electron, gives that electron to an atom of chlorine, which has 7 valence electrons. Now, the sodium ion has the same electron configuration as the noble gas neon. By losing that extra electron, it has a full octet of valence electrons. The chloride ion, by gaining an electron, now has the same electron configuration as the noble gas argon. The oppositely charged ions, which are strongly attracted to each other, arrange to form a lattice in 3 dimensions, where each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. Let's do another example and use electron dot structures to determine the chemical formula of the ionic compound formed when potassium and oxygen react. Potassium is a metal that has 1 valence electron. Oxygen is a nonmetal that has 6 valence electrons. A potassium atom will lose 1 electron and will become a cation with a 1+ charge, and so will have a filled valence shell. In order for oxygen to have a filled valence shell, it has to take on 2 electrons. The oxygen anion has a 2- charge. In order to balance that -2 charge, it has to bond with 2 potassium cations, which are each 1+. So the formula of the ionic compound is K2O, potassium oxide. Ionic bonds, like those in NaCl, are often easily disrupted in water. The ions separate and are surrounded by water molecules. We call this a solvation shell, or hydration shell. Notice that the water molecules are arranged so the partial negative oxygens in water are oriented towards the positive sodium ions, and the partial positive hydrogens in water are pointed towards negative chloride ions. Because the ions can move freely when dissolved in water, aqueous solutions of ionic compounds can conduct electricity. Not all ionic bonds are soluble in water. This isn't something you can figure out just by looking at the periodic table. Solubility is determined by experimentation. You may have seen a table of solubility rules. That's a summary of experimental results. Ionic compounds involving nitrates, for instance, are all soluble in water. Most chlorides, like NaCl, are soluble in water, but there are some exceptions, which include the chloride compounds involving silver, mercury, and lead. Despite often falling apart in water, ionic bonds are considered strong bonds, as are covalent bonds. We'll compare their relative strengths in another video.